3, and we're on lesson 7, and we're going to spend a little bit of time talking about your old friend's domain and range. So for the functions that we graphed before, y equals 2 to the x and so on, we know that our domain was generally x is an element of the real numbers. It can be anything as you go to the left and to the right. But if we're talking about real-life application problems, that's not always very valid. So the first thing that we looked at was pizza toppings. And we have a graph below that things would double. The more toppings you allow somebody, the more potential choices that they have. So if you had 0 toppings, there was one choice, plain naked pizza. If you added 1 topping, you now have 2 choices, plain naked pizza or one with a topping, and so on. Your choices double every time you added a new topping. So if you can see where I've added the green, that was the graph of the pizza toppings. Can x, or the number of toppings, be any number? Well, it wouldn't make sense to offer somebody 1.5 toppings. I know we do that sometimes on a half a pizza, but you're still doubling your choices. X isn't really a real number when we're talking about pizza toppings. X would be a whole number because you could have 1 topping, 2 topping, 3 toppings, but you wouldn't have 3.74 toppings. It doesn't make any sense. And also you wouldn't have negative toppings. We probably have an upper limit on number of toppings, but I don't know what that is. Could you come up with 25 different toppings if I gave you enough time to think about it? I don't know. But I do know that it would not be negative, and it would not have decimals and fractions. We would have whole numbers for our domain. For the range of pizza toppings, it wouldn't make any sense to have a y value that's negative, and they aren't for exponential functions anyway. Is there a certain number of pizzas possible that gets to a certain upper range? I don't know. But I don't think you can have 15.25 different types of pizzas and different choices. Your y would be a whole number as well. Email frenzy. It's when you tell a friend and they tell 3 friends and they tell 3 friends and so on. And we have a curve that gets steep fast. Do watch out for gossip. That happens rather quickly. Can you have 1.5 people that send out emails? Probably not. Can 7.5 people now know the news? Probably not. So probably your x and y values wouldn't make sense to be real numbers, and certainly wouldn't make sense to be negative. We would probably have these values as whole numbers as well. And we would not join them together because it wouldn't make any sense to draw a curve like that when you know you couldn't have 1.5 people telling 4.5 friends about the email. So we wouldn't join those dots because it's not continuous data, it's discrete data. Let's think about the car depreciation. This one is an interesting one. So if your car is $32,000 and you are losing 20% each year, which is a very sad thing, by the way, your car goes down in values like the graph in front of us. Is it just whole numbers? Does your car jump from $3,200 to $3,199 and so on? No, not exactly. It can go down by pennies and dimes and so on, but only to 2 decimal places. Can we join those dots and use those values in between to estimate the value of our car? I suppose so, but only to 2 decimal places. I would say that x is a real number, but make note of the fact that it's in dollars and cents. Can x be negative? when you're talking about the value of your car? No, not really. I suppose we could look at its value the years before you had it, but it wouldn't make any sense to have a negative values. So we would have our x is greater than or equal to 0. Our y value never goes to 0. So your car is always worth something, even if it's only just for the metal. In fact, I got 20 bucks for a car once. Anyways, my y value, which is the value of my car, would be a real number, reminding myself that it's in dollars and cents. But it would have to be greater than 0 and less than $200, because it can't go up in value if it's depreciating. So we're just thinking about what makes sense once you're in real life problems, and I'm going to have you and your friend have a look at the next 3 pages in our course notes and just consider the domain and range and the types of functions that you're looking at.